Assalamualaikum warahmatullahi wabarakatuh. My name is Irfan Murtirazi. I am a student at Information Technology Department Science and Technology Faculty, State Islamic University of Arniri, Banda Aceh. So today, I will review the journal with the title Comparative Study of Decision Tree, Kidney Snack Bar, and Modified Kidney Snack Bar on Jatropha curcus Plant Disease Identification. This journal is written by three people. The name of the first. Triando Hamonangan Saragi from Computer Science Faculty of Mathematics and Nature Science Lambung Mangkurat University Indonesia. And then Dini Melsi Nurul Fajri from Magister of Computer Science Faculty of Computer Science Brawijaya University Indonesia. And then Alvita Rahmadansari from Magister of Computer Science Faculty of Computer Science Brawijaya University Indonesia. Next, abstract. Jatropha curcus is very useful plant that can be used for research against repelling the cold. In Indonesia, there are few plantations that plant Jatropha curcus, but there is so limited farmers to understand in detail about the disease of Jatropha curcus and its might cause a big loss during harvesting when this are with no further action. An expert system can help the farmers to identify the land disease of Jatropha curcus. The objective of this research is to compare several identification and classification methods, choose a decision tree, kidney snack bar, and its modification. The comparison is based on the accuracy. Modified kidney snack bar method given the best accuracy result, that is 67.74%. Next, introduction. Jatropha curcus is a plant categorized as shrub plant that can live in the area which has low rainfall. For industrial use, Jatropha curcus can be used as diesel egg fuel. Like their other plant, there are a few plant diseases that can attack this plant, such as bacterial weeds, Actronus, Fusarium wilt, like black charcoal blue, and powdered milk. But unfortunately, the farmers have just few knowledge about this plant disease, so it can be harmful when disease also. The plant disease needs the identified phase, so farmers know further action in order to avoid big loss in harvesting season. An expert system that implementation expert knowledge can be a solution for robust plant disease identification. For obtain the high accuracy of the other several classification methods on data mining, such as decision tree, kidney snack bar, KNN, and modified kidney snack bar MKNN different with KNN, which classification the class only use the included distance. In KNN, the classification is based on the validity of a training data and the included distance to calculate the weight voting value. We went to observe and compare the accuracy of methods, so it can visit the other trace to get a high accuracy than previous studies by using the main data classification methods. Kidney snack bar KNL also can be used to solve classification problem. So the kidney snack bar method with result from the next instant bring classificates based on the kidney snack bar categories with hint for algorithm the classify new object based on attribute and simple from the training data. MKNN is method of determining weighting of parameter key in the KNN and weighting parameter is determined by using a different procedure. the first thing to do including of the validity of training data. Furthermore, the calculating of white voting on L test data using the data validity, so that every data in the training data must be validated first at first. In validating its data depending on the voting poll, it is necessary to know the validation process for all data on training data. Next, research methods. In the paper, author implemented three different approaches: decision tree, KNN, and modified KNN to identify heteropacorcus disease from same dataset. First, decision tree. As we can see in the classification figure, big fat decision tree that describe the rules into database language, such structured query language. The classification method is will show the classification and relation between attribute. Then the decision result with the expert final result in the decision tree applicates. It is necessary of the kernel that the advance of decision tree is that is able to solve the decision making process from decision making result in the solution the problem. We can see together in the decision tree image using a hierarchy structure consisting of root nodes, internal node of left node. The root node is the node which is located in the top. Internal node is not breadth which has only one input and has at least two outputs. Left node is the last node which has one input and has no outputs. There are some algorithms we can use from a decision tree, such as ID tree, split, S-link, public, and other. 2. Key-ness snackboard. Ness snackboard in the upper looking for case to calculate the closeness between the new case with old case vision of making the weight of number of existing feature. Problem solving step using KNN algorithms. 1. Determine parameter key, which show the number ness snackboard. 2. Calculate the square of Euclidean distance between object and data sample. 3. Sort the object by Euclidean distance in ascending nodes. And 4. Classify reading and class based on the previous step based on the class that must appear on the key-ness snackboard. Next, 3. Modified key-ness snackboard MKNN. To implementation MKNN, we make sure the validity training data first before calculating the weight voting. Training data validity. Validity is used to calculate the number of points with the same label for all the data in the training data. The validity of any data depends on any snackboard. After the validating data, then the data is used information. About data, the equation 1 used calculate the validity of a training data, where H is the number of node point LBX is class of X, ni X the class label of node point X. C function is used to calculate a similarity between point E and B node snackboard data. C function is define the equation where is that data in the training set will be is not older class B expert E in the training set. Weight voting. MKNN method the weight of snackboard first calculate using 1 plus 1. Then the validity of any data of training set multiplied by weight based on Euclidean distance. So the weight of voting of a snackboard and calculate for equation 3. where we X the white voting calculation and the is include distance. Next, result and decision. In this, results are grouped into two, that is training data and test data. Training data was obtained for experts of Jatropha Plant Disease at Indonesia Crop and Fiber Crop Research Institutes. Test data were obtained from distant observation data at Jatropha Plantation in Situbondo. In this section, testing for earth method and obtain result of the accuracy described as flow. Next, decision tree. Testing has done 10 times using 31 testing data. In construction of decision tree using a genetic algorithm that has 5,149 kinase of its chromosome. Result of figure through can be using the chromosome size metric with size 9/61 as length on the metric show for one step of this. There are 9 lines of row that show the value of 9 steps on Jatropha splendis. Each rows consist of 61 gains, in which a pair of gains to a given genus show the observed variable of Simpson. So based on table 2 and the high accuracy result when the second test is 22.58%. Accuracy often is because the use of this method is often obtained a trait that can be categorized more than one of type of disease with the suite of fluid. It also very useful to describe the criteria of other types of disease so that some diseases then appear more often as classification. Kinase neckboard. Testing has done by testing the value of key and testing of training data. We use 155 training data and 31 testing data. The key value testing aims to how many neckboard draw the nurse with give a good accuracy value. This test use the key value of multiply 5 and use 20%. Training data by available to training data. Visit on the table 3 can be seen the value of key by 15 has the high accuracy 45.60%. Key value of 15 for the convention and after 10-15 are implement value. The next step is using the data variance. Test data use multiplication 20% using key equal 15. So testing of training data in the table 4 flows. The data training as smooth 100%. Give a maximum accuracy of 51.61%. This proof that is training data 100% has separate of data training and provided a better solution. Next, modified kinase neckboard. In KMN method, a computing experience has been done by testing of value key and testing of training data. From table 5 show that the value of key by 15 have the high accuracy 61.29%. Key value of 15 proves the combination and after 10-15 and impress value. The next test is using data variant. The test data use multiple 20% using key equal 15. So that testing of training data in the table 6 proves the training data as much 16%. give a maximum accuracy 67.74%. This proof the training data 60% has spread of training and fully and provide better solution. The unexpert data training course describe accuracy when using all training data. Thus in the table 7 show that best accuracy for all methods 67.74%. Result by modified Skinner Neckborn method, MKNN method can provide better accuracy because this method provides the calculation of validity value at training data based on Neckborn with separate between search space and has the same class label the first step. This can be when data has big value of validity, then it will be good. Reference to classification is that class label based on included distance. Next, conclusion. The method that have been tested of Jatropha curcus identification case are often with the high accuracy is the MKNN method with an accuracy of 67.74% using 60% training data, and third one testing data. This result can still be improved for the better by training tools. Other method for further research choose a hybridization with genetic algorithms, natural network algorithms, or super vector machines. Okay, thank you for reaching the review journal. Justice for me. I'm so sorry for mistake. I close this meeting with salam. Wassalamualaikum warahmatullahi wabarakatuh.